Hello, welcome to OCC Math Seminar session. Today we're going to compute in some derivatives. Oops, I don't know why this is blank space there. I want to compute y equal 3 tangent of x squared minus 3. Be careful, this is not a multiplication, okay? Tangent of x squared minus 3, right? There's no multiplication there, but rather the multiplication here. Right? Since 3 is the constant, we leave it alone. We're going to compute the derivative of tangent x squared minus 3. So the derivative of tangent is secant square u times u prime, right? So this is equal to 3 times secant square times u. U is this one. That's u. Right. So secant square u, so secant square x squared minus 3 times the derivative of u, which is 2x, just 2x, right? Derivative of negative 3 is 0. And let me rearrange this. 2x times 3 is 6x times secant square of x squared minus 3. B, y equal 2/3 times 3 to the 3x minus 2 sides of 3x. All right, so this is a difference of two derivative. So I should say y prime here. So y prime is equal to 2/3 is a constant, so leave it alone. Now, derivative of AU, so this is a to the u power. Let me remind you, derivative of a to the u power is a to the u times u prime times ln of a. Right here, a is the base is 3 here, so that is my base, right? U is the part 3x there. So equal a to the u, so 3 to the 3x times u prime. U prime is 3x prime, which is 3, times ln of a. A is 3, so ln 3. The base is also 3 here. That's the base. All right. I can cancel this one with this one, right? Now, please do not cancel this one with this one. It's not even possible, right? One is just a number 3. The other one is 3 to the power of 3x. Right? So those two things are different. But the 3 here in yellow, they're the same thing. So we can cancel. So I have 2 times 3 to the 3x times ln of 3. And please do not combine the two together, become a 6. I see people do that. I know it's tempted, but we don't have any rule that allows us to do that, right? Those two are different things. And that's it. That's your solution. Oh, I forgot the 2 times size, negative 2 size 3x. I'm sorry about that. So that's one thing. Let me do this. So that's one part. The other part, maybe I use green. The other part is negative 2 side 3x. So I'm gonna say y prime 1, y prime 2. Again, I'll use green, like I said I did. Is the negative 2 is this constant, so we leave it alone. So negative 2, right? Derivative of psi u is cosine u times u prime, right? So times cosine of u is 3x, times u prime, so 3x prime is 3, just equal to negative 6 cosine of 3x. You combine together, I have the overall derivative, 2 times 3 to the x, ln of 3 minus 6 cosine of 3x. I want to find the derivative of log base 5 of 2x minus 3. Derivative of logs, so let me remind you, I have derivative of log base u, or log base a of u is equal to u prime divided by, or rather that u prime is the same thing, but rather u prime times 1 over u times ln of a. Here is your base, right? The base here is 5. So u is this blob right here. Right, so equal u prime is 2x minus 3 prime, which is 2, times 1 over u, which is 2x minus 3, times ln of a, ln of 5. And you're done, right? Maybe you want to rewrite it, make it a little neater. 2 over 2x minus 3 times ln of 5. D is you require quotient rule, right? So quotient rule say this: if I have function f divided by function g, and the derivative of that will be f prime g minus g prime f divided by g squared. So the numerator will be your f, the denominator will be your g. f prime, let's see, f prime is 2x squared minus 7 prime, right? So that'll be 4x, just 4x, right? 4x times g is 3x plus 1 minus g prime is just 3 times x, which is 2x squared minus 7 divided by g squared, which is 3x plus 1 squared. Maybe let's clean this up a little bit. 12x squared plus 4x minus 6x squared plus 21 over 3x plus 1 squared. Y prime equal 6x squared plus 4x plus 21 over 3x plus 1 squared. I don't think we can simplify any further, so we leave it like that. Y equal x cubed minus 2 to the 10 power. So this is chain rule, right? This is your u. So 10 equals, so y prime equal 10, bring the 10 to the front, 10 times u prime, so 10 times x cubed minus 2 to the 9 power times the derivative of the u, which is 3x squared, right? Derivative of negative 2 is 0. 3 times 10 is 30, so 30x squared times x cubed minus 2 to the 9 power. This one may take up a little bit of space. Right, I want to find the derivative of ln absolute value of secant x minus tangent x. Right, so ln I can rewrite it as log base e. Right, ln is the same thing as log base e. Now remember, derivative of log base a of u, I just wrote it up there, right here, right, is u prime times 1 over u times ln of a. Okay, so let's do this. Here I'm going to rewrite it like y equal log base e of secant x minus tangent x. It's absolute value because you don't want, log cannot take negative input. Then u prime, remember u is this part right here. That's u, right? So secant x minus tangent x prime times 1 over u, which is secant x minus tangent x. Maybe I'll do like this, so I don't have enough space. I just put it over. The same thing. Times ln of a. A here is e, but we know ln e is 1. right? This part right there, that's 1. Let's give us 1. The derivative of secant x minus tangent x is the derivative of each of those. So derivative of secant x is secant x tangent x. The derivative of tangent x is secant square x over secant x minus tangent x. I'm going to factor out negative secant x. Then I have what? I have, yeah, I'll do one more step. So that I'm gonna factor out secant x first. Eventually you factor out negative secant x, but let's just say you naturally you factor out secant x first. What's left is tangent x minus secant x divided by secant x minus tangent x. Well, this one, the opposite, right? You can factor out the -1 on the bottom. This is, or -1 on the top, doesn't matter. Maybe we factor out the, say we factor out the -1 here. So what's left? Tangent x minus secant x, right? And now you can cancel, right? And leave a -1 on the bottom. So the final answer will be negative secant x. Good luck with the derivative. Thank you for watching.